Hi everyone, my name is Fred. I'm from NCI Australia. This work is jointly putting together by my colleague Jimbo and the Barrett in this meeting from Nvidia Corporation. So in today's talk, I just want to take you guys to this story and get some insights about hosting hackathon at NCI in Australia. And we'll just go through some different perspectives for these events and have a look at the applications that we have been helped assisted in the past 2 years. So before we get started, the National Computational Infrastructure acknowledges, celebrates, and pays our respect to the Ngunnawal and the Ngambri people of the Canberra region and to all First Nations Australians and whose traditional lands we meet and work and whose cultures are among the oldest continuing cultures in human history. So for those of you who are not familiar with NCI, so we are a world-class high-end computing data science hub in Australia. We are the premier facility in Australia providing basically three types of services: the traditional high-performance computing services empowered by our supercomputer Gaudi, which consists of about 250,000 compute cores, and we also have the cloud computing and the data storage and the service provided in-house. Overall, we supported I guess at the peak time we supported over 8,000 Australian users. Well, slash international, mostly will be Australian. So this is sort of the trade of our services. We tend to host a large number of users coming from different backgrounds. And another trade that we're very proud of is our machine. Our supercomputer Gaudi runs 100% green grade. This is another very distinguished feature of our machine. Overall, we deliver outcomes with national benefits. So what we're going to talk about today is the hackathon at NCI, and we're going to go through this to get some insights. We're going to go through this from 3 different perspectives: the organizer's perspective, i.e. NCI, and our collaborator Nvidia, and also from mentors' perspective, because they are the critical parts for the success of the hackathons, and finally the user's perspective. So the scope of NCI, the scope of the hackathons that we run in NCI is we want to provide in-house HPC code refactorizations through GPU porting and GPU optimization. We do this by this methodology: analyze, parallelize, optimize, and debug. The acronym is APOD. Through this procedure, we usually firstly start with analyzing the code to determine most likely places in the code, in user's code, needing parallelization or optimization, because usually the hackathon, the time length we have is about 2 weeks. First week online, second week it will be in person. Given this time constraint, it's a bit unrealistic to work on the code from top to end. So for the practice, for the best practice, we would like to identify what is the bottleneck of the code and what kind of optimization for that part and the parallelization for that part. So once we identify that part, we would parallelize the code by starting with the most time-consuming parts and check the correctness, because reproducibility is one of the most important aspects of scientific computing. Then we'll continue to optimize and debug code to improve observed speed up from parallelization. So this is the sort of the workflow we conducted basically all the applications in our hackathons. Okay, so from an organizer's perspective, what we want to do this because we want to have the HPC that accommodates everyone. Like as I mentioned before, NCI, we host a wide range of applications in the projects and from users. As of today, we have 3,478 projects. They were written different codes, different parallel programming models, and 6,410 users. And not everyone is HPC proficient. To this end, NCI training team was established back in 2021. And since then, we ran regular training events, including boot camps in collaboration with Nvidia and CSIRO. For those of you who are not from Australia, CSIRO is the the national science agent that we have a very close tie with. So we run the boot camps. We also develop training materials, in-house training materials for domain specific topics. Overall, as for now, we have 31 events and 254 training events and 2,655 registrants just for this year. Okay. So over the training sessions we run, we would have we often have users want to continue to optimize their code. So from those training events, user will be sometimes users say, okay, because we offer those HPC tools in a bit more general form, but they want to use those tools for their own specific problems. So yeah, I put sentence here, okay, learners are using cooldown on your heat equation toy problem, but now I want to do this with my code. And this my code X could be, it could be traditional written in traditional C++ for Fortran. Well, more likely it will be in Python in nowadays landscape, and the other languages, well, Julia. And the last in 2022, we actually had a application brought up from the users that was written in the language, and that was a fun project to work with. And of course, from time to time, we will have users want to improve the efficiency of the code, but the code is proprietary software. Okay, so this pie chart here just give you a sense of the programming languages brought in NCI hackathons. Half of the Python, and a third about of them is Fortran, C++, and the rest of the other different languages. From continue on this, organizations, what our responsibility from our perspective, we'll need to prepare the venues, catering and stuff. This is the licensing organization's responsibility, and then of course we need to find the mentors to match applications. So we actually need to find someone who are capable with the knowledge to help with the users. Okay. So source mentors, in our case, we source mentors mainly from the hosts, that is NCI and Nvidia. They have a great talent pool. From time to time, we also need help from the community. So those Pumas AI and Julia Lane, we have the wonderful help volunteers from them as well. And because we're based in Australian national universities, we also in the past have academics from ANU to join us. So from mentors' perspective, the number one question we'll need to answer is, why do I need to volunteer my time on someone else's code? As for hosts, we tell our colleagues, this is the chance, we learn from our users so that we can provide a better service. So we have this opportunity to work face to face to understand users' code. And as for upstream developers, Hackathon provides this opportunity to work directly with the users and see limitations. At least the few of the cases that because I was a mentor last year, and I was working on one of the code, and we see a few of the limitations that could be brought back to the upstream developer and to improve the toolkits. One of them is I think that's Fortran code. Iterative copy, so the code has like massive hierarchical data structure, and if we want to just copy in the bottom data structure in Fortran by OpenACC, then we'll have to copy in all the parents ones. That was pretty weird for us, but then we realized we can't do hierarchical iterative copy at that time. Maybe as things have been changed. Another thing we noticed was the size of loop construct is limited in OpenACC, but this is at the time the code has a massive 3D 3D fine difference for loops, and the OpenACC clause can run into crashes because just number of lines that is under the OpenACC for loop. Another problem we found was ANSYS fluent GPU usage was poorly documented in the case our users our users application. Okay, so if you are the mentors from the research community, then this is again a good chance to be part of the research innovations and to get to know other members of the research community. Lastly, from users perspective, what we see is we have a shift of applications. In the first year we ran this in 2022, we had 1 AI/ML project, and this year as we had 5 of the projects AI/ML, and 2 of them are large language models. And those 2 large language models are in material science and the bioinformatics. This sort of reflects, the trends in this HPC and AI area. But we still see various traditional HPC applications, and some of them are real life applications that have a high impact. We have applications that is trying to solve natural disaster, trying to get better natural disaster prevention, such as flood simulation, bushfire simulation, because Australia is more often got plagued by the natural disaster. So we are very happy to support this code. And of note, the flood simulation code, Anuga, we helped this year. So that code was developed in ANU with Geoscience Australia, but the application was brought in by the Indian CDAC agents because they use that code heavily in India to manage their natural disaster. And this hackathon this year at the NCI actually provided perfect value for both the end users and the developers. They actually sit on the table together throughout the 2 weeks and work on the code together. So that was something, as a host, we're really happy to see. We also have applications that comes from national security and more for fundamental sciences. To wrap up, I'll just give a glimpse of the results. So the code we've been working in the hackathon got some level of speed ups. Depends on how well they were parallelized before, and it will depends on the nature of the code. I have selected some of them, so range from I think 3 to 100 times. There were a few applications that got 1,000 times speed up because they are embarrassingly paralleled. So as soon as we get work on the code, the users gets this magic parallelization pretty quickly. Yeah, so overall, this event has been very helpful for the users, and we continue to help with them in their future development. Just a few family photos. So this was taken in the last year's hackathon, and this is this year's hackathon. So yeah, in summary, I quoted from one of the application team application. The hackathon is the best place to fail 99 times so that you can succeed and on the 100th try, by Brenda. So, okay, thank you for your attention.